Welcome. Thank you very much for deciding to attend this session. This is a session organized by CODATA, the Committee on Data of the International Science Council. We decided that rather than doing an organizational session, that we wanted to do something substantive. And this session forms one of three that we've organized. The plenary yesterday morning, and one of the parallel sessions yesterday afternoon that look at issues around AI from various perspectives. Yesterday in the plenary, you heard about rigorous, responsible, reliable science in the age of AI, and three fantastic speakers. Yesterday afternoon, we had a session looking at the role of metadata in AI readiness, and also the role of AI tools, generative AI, in enhancing metadata and in semantic mapping. And today, to continue that discussion, we're going to look at AI for science, the role of AI in the creation of scientific knowledge, and really how we adapt our science systems, our methodologies, etc., to these new opportunities and challenges. We have 4 presentations, 5 speakers, I think. One of them is a double-header. First of all, Mercè, who introduced the session yesterday morning. Mercè Crosas is Director of Computational Social Sciences at the Barcelona Supercomputing Center and CODATA President. She will talk about becoming AI-ready in science. Then we will hear from Vanessa McBride, who's the Director of Science at the International Science Council. And that will be the launch of 3 policy documents that ISC has prepared on various issues relating to AI in science and how our science systems, with recommendations for how our science systems respond. Then Christine Kirkpatrick, who's Director of Research Data Services at the San Diego Supercomputing Center and CODATA Secretary General, and Tyng-Ruey Chuang, who's an Associate Research Fellow at the Institute of Information Sciences at the Academia Sinica in Taiwan, and a member of the CODATA Executive Committee. They will present a work in progress, I think, a white paper that CODATA is preparing and that they are leading on the role of AI in science. And they'll be looking for feedback on the recommendations that they're making and the arguments that they're presenting. And then finally, our head of AI and interoperability, Slava Tykhonov, will talk about some of the practical applications of AI in research data and linking Semantic, Croissant, and the cross-domain interoperability framework for responsible use of AI in science and in the management of research data. And after those 4 presentations, we should have 25 minutes or so for discussion. So while those presentations are happening, please do think of questions and things you might want to contribute to that discussion afterwards. So that's the menu. I hope you haven't had 2 large breakfasts, and that is of excitement for you, and that you have a good appetite for that discussion and those topics. And with no further ado, I will do I probably should have done this first. The acknowledgement of country. We acknowledge and celebrate the first Australians on whose traditional lands we meet, and we pay our respects to their elders, past and present. And with that, I'll hand over to Mercè.
Thank you, Simon. And thanks for coming here. It's our 3rd day of the conference, and it's nice to see people are still getting up to come to the talks. So, and we hope we have a good discussion after these presentations. So first, I will start with just a slide. You don't need to read all these texts, but I just will explain it to you, just to give you some background of why CODATA is interested in this topic and what part of AI in science or for science CODATA is interested in. So CODATA was created in 1966, and at that time, in a nice book about the history of CODATA, that you can read that text in the CODATA website. It talked about, well, the challenge that was occurring at that time with new automated instrumentation made it possible to perform physical measurements much more efficiently, right? There was all these new tools that generated a lot more data. And the researchers, the scientists got together to say, well, we need to have, with this expansion of amount of data that is being produced in science, we need to agree on some standards and the way that we're going to share it, in the way that this is going to be interoperable, in the way that we're going to be prepared for all this, to make the better use of this data. And this is part of why CODATA was created at that time. But now we have a new instrument, very powerful, right? AI, that it's, well, it takes a lot of data in, and also it has the capacity of producing a lot of new data in new forms. And we also, I mean, there is a role there here in CODATA, as it were, it was at the beginning of it, that to prepare for that, right? And to make sure that we can make use, efficient use of this data, and responsible use of this data. So, for this talk also, just to continue giving a little bit of background, I'd like to describe what we understand for AI here, because as all of you know, AI was not born with ChatGPT. AI has a history of decades, right? And during this history, there have been many definitions, but the standard one now that you can read about it in the Russell and Norvig book that has a very good, long summary introduction into AI. So AI now, the current standard of AI, how it's understood, is the study and design of agents that do the right thing. And the right thing means that they achieve the goal we set for them, right, without human intervention. So starting from that and seeing the history of the technologies and the methods that AI has applied since the 1950s when the concept was started, right? So it has gone from more a rule-based AI with expert systems that have been used broadly in many things in our life. This is sometimes referred also to the symbolic AI or the top-down AI. We set some rules in the algorithms, and then that defines the behavior, that automated behavior, right, without human intervention. That also brought the autonomous agents and robots. But then in the 80s, there was the big explosion of machine learning, again, having a lot more data to be able to process, that led to this connectionism or the bottom-up AI. And that led later to deep learning with neural networks. And then after that, with NLP and computer vision and so on, it created the transformers, which is now the basic models, right? The algorithms that help or created the generative AI and the large language models that we all know. And there is indeed an explosion of large language models. Even this slide that shows the growth of large language models in the last years, just only in 4 or 5 years, right? It's probably missing already many because this keeps getting updated year by year, or month by month even. But just to give an idea that as all of you know, there are these more paid licenses AI models or LLM models with many parameters that have been pre-trained with huge amounts of data. But then there are also open source models. Sometimes are a little bit smaller in size, but still quite reliable, with taking into account that all LLMs have hallucinations and need to be cautious how to use it. And that's why for science, there is a better approach often to create AI in a way that it's fine-tuned. And in this case, one example that everybody knows, the AlphaFold, mostly you probably know because of the Nobel Prizes from last year, not this year, last year's in 2024, for the creation of this AI model. And AlphaFold has been, well, it's used very widely now, but really, it was, even though it's based on transformers, it's not an NLM as ChatGPT, but it's based on the same models, right? But or a variation of those models, new versions. But it's there thanks to large amounts of curated data that started already in the 70s with the Protein Data Bank. And so this is not a massive LLM, but and it requires less computation than the very large LLMs, but it has a specific purpose, and having this selected data and curated data and relevant, it's more appropriate for what it needs to do in terms of generating new, the structure of proteins, right? So here. But so in a way, I mean, AlphaFold has been very successful. We still have a lot, we can build still a lot of foundation models for science that have not yet been built, and we can do it with curated data that we have or we are generating, and with for a specific purpose. And for that, it's very important, I mean, whether it's foundation models or fine-tuned models based on existing LLMs, right, or existing other AI models, it's very important in order to do that the LLM is open. The original AI model that you use is open source, so that you can then deploy it in your cluster, in your supercomputer, in the computational resources, right? And you have more control of what the data that goes in, and also you can use it even for privacy, for sensitive data, right? If you have the right settings, and then you tune it for the purpose, right? And when in one of the recent preprints, that do an evaluation of comparing using general purpose LLMs that are, well, have a lot more parameters, but with these fine-tuned LLMs for a specific purpose, it compared very well that usually it was better, more efficient, or more less error prone than the large LLMs. Or similarly, this is similar performance depending on what purpose. So, on the other hand, when we talk about of open AI models, right, or open source AI models, we need to be a little bit careful because open source doesn't always apply anymore to, or it's not sufficient basically to describe open models. And I think that here OECD just has done a nice job of reviewing what, or making us aware, right, of what AI openness is. If you look at this AI openness, a primer for policymakers from OECD, I think was just in August 25, so not that long ago, was published. We see that AI openness includes many components, right? It's not just one thing, and it's not be open or not open. It's not a binary. It is a spectrum. So, and in some ways, like data, it's not just open or closed. There is also a spectrum of access to data. So, for AI openness, you can think of the data sets, whether are the pre-trained data sets, the ones that do you use for pre-training the foundation model, or the training data sets that you use for fine-tuning, or the evaluation data sets that could be for validation or testing of your model. And then there are the model weights and whether those are open or not. Then there is the code for the code itself that you use for training. Then there is the fine-tuning or the inference code, right? Whether you're using just the LLM as it is, or the AI model. I keep saying LLM or AI model because sometimes it's not necessarily an LLM, but maybe it's a model based on NLP or computer vision or other, so that it's not based on a transformer, but still it's the same, that whether you use it just for inference directly or you're fine-tuning, you're modifying it, right? You're adopting it for your specific purpose. So, and then the documentation, right, is also is open or not. So there are many components that you can have more or less openness depending on how transparent you are in all these parts. And that's why OECD concludes that open source does not fully capture the specifications of the specificities of AI systems. And when we talk about open weight AI models, we're referring that the trained weights are publicly available, which is very important for fine-tuning. So the other thing is, as we all know, the importance of data in AI, right? We are here in the International Data Week, and we care about how AI is used in science, because data, is the starting point for building AI models and for using AI models. So because of that, we need to think of what data is going to be the most relevant for training our data, our AI models. And we heard yesterday from Ana Arjona about the dangers, right, of what is the proxy for your research questions, right? Is that the data the appropriate one that you should be using? So finding the relevant data, it's not always easy, but it is important, right? If you're going to train or you're going to use an AI model through inference or through fine-tuning. We know that the challenges that sometimes we need to merge those data sets to be used for the training, and they are not interoperable. Sometimes we have issues with sensitive data, and we need to be careful also what are we carrying in the training data set that maybe could be re-identified in the outputs, right, of the AI model. And we also need to, worry in general that we're not entering now, capturing more data from text data from that is being created all over, that we're not entering this information. At the same time, we will see also is Slava's talks later that how and with other talks that throughout this week, how also AI models, the use of AI can help us to enrich and prepare those data sets for use for training an AI model. So then we come to the definition of AI readiness. You will see later on with, I think it's, from Kristin's definition, or, Kristin and Tyng-Ruey definitions, that might be a little bit different. I just wanted to just make sure that we understand that we're still defining what AI readiness is. We still, as a community, wanted to understand how would we need to be prepared in terms of in the context of the research life cycle and the data that we use so that we have the appropriate data and for workflows. Here, the way that we define it, what we mean here in AI readiness when we use it in the examples that I will be showing you, is that AI readiness, is everything that concerns documenting the data, the models, and the computational workflows, right, towards using AI. And this includes data preparation, includes data quality, includes data description, and data access. And it can include even more, but at least those components. And then I just want to distinguish between machine actionability, because very often I think we talk about AI ready, and what we're referring really is just the machine actionability. And AI readiness it goes beyond this actionability. The machine actionability is very important, and of course the FAIR principles had both the human, they are made for or set for humans to reuse the data, but also for machines, very importantly, right? And in this definition, that it was from one of the papers that we wrote after we wrote the FAIR principles, was that was in the interpretation and implementation considerations for the FAIR principles. It defines it as enable the machine actionability is enabling machines to make optimal use of their resources, allowing them to be used as an agent or substrate for ML AI approaches. So it prepares it for AI use, but it's not sufficient. In this new research life cycle, when we're introducing the use of AI, whether it is for, again, inference or fine-tuning or modifying or doing a RAG, or using an AI model. So we still have some of the same components that we're used to seeing in a research life cycle, that it loops in some way, that from all the way from data acquisition and what data do you start with, and then preparing that data. But in this case, it's not only preparing the data, it's selecting the right AI model, and this is also an experiment on itself, which AI model will work better than processing the AI model, and with that, the computational workflow that will help you with this. And then there are the outputs that we want to make sure that are shared in a way that it's fair. And here I put some of the the elements or the standards and already initiatives basically that are helping to document this research life cycle when we have AI. And of course, there are other ones, but that's the ones we've been working on in our examples. So Croissant is part of it, ArrowCrate is part of it for and adopting it for this AI model, AI-based research life cycle. And then we have the repositories that in our examples we use Dataverse, and then to create reuse that data again, or building tools that will help us prepare data for new AI models. We also use DDI and some of the other recommendations from the cross-domain interoperable framework. So I have very little time for two examples of things that we're working on. It's a work in progress, but we're working on the Barcelona Supercomputing Center with computational social sciences and humanities. Some of the people in the team, Abdallah and Joan Gené, are here, and you have seen some talks from that work. Probably in these days, but just very quick, the first example is an example that is about AI in science, but at the same time is using AI for the study, right? So it's a study that the topic is how we use AI in science, but using a large-scale inference of LLMs. In this, the preliminary, preliminary results for AI in science are showing how in life, if we take more than 200 million abstracts from OpenAlex of all the scientific production from the 60s to now, we see that there is an increase in the life science, in the AI use. I mean, this is how AI is used in the methods, not just that it's mentioned or that the paper talks about AI, but it actually the method section have used the AI, right? So in all domains, in life sciences, social sciences, physical engineering, computer sciences, and health sciences is used. Of course, in the computer science leads the use of AI. In this, you will see in this plot, right? What we see from these studies that usually is one field in every domain or one or two fields that are really leading this use of AI in science, and the others are lagging behind. In the case for life sciences, we see neuroscience, and in the case of social science, we see the decision science or business management. We also see that the papers or the scientific production that uses AI in the methods, corresponds to an emerging has the properties of an emerging field, right, where you have a higher citation rate for those papers, but you also have higher retraction rates, actually quite high in the social sciences. And you see also very quickly a map. I know that my time is up, so I'll just I'll go very briefly through the second example. But here, just you will have all these slides also available in our site. But so you could look at that in more detail. But really, this is a workflow that what I mean, the point here is really that the new workflows where we use inference in LLM and an open source LLM needs to be documented well, and this is a new type of life cycle or pipeline, right? That now we're starting to use in science, and the description and the metadata needed to describe this kind of workflow we're still working on it, but the idea is that we want to make that workflow replicable and reusable by others, right? And as you see in every case of the example, there is always very important the part of validation and testing. So it's not enough to just use an LLM for inference and ask some questions and get the response back. You need to validate it manually or with previous other methods that have been used in the past to first find the uncertainty or the accuracy of the model of your method, right? The second example, very quickly, I know I'm out of time, but just so you know, some other research that we're doing is quite different, but it's for, transcription and analysis of medieval archives, in this case, from the 13th century to the 15th century. They have never been transcribed before. It's been digitized, but there is a lot of content, a lot of history, a lot of, new perspective and history that we have not been able to have the research questions, right, by these huge amounts of, in this case, notarial manuscripts from Barcelona, from Catalonia, which has a lot of information, a lot of archives from those centuries, almost the most in the world. So in this case, also we use some of the manuscripts for the training, for the validation and the testing. We experiment with different AI models to see for the transcription, but also, I mean, there are several processes. One is segmenting, then the transcription, and then the actual analysis. And again, this is my last slide. We need to document this type of new workflows, in this case for fine-tuning. I mean, the first example was inference, and this one is more fine-tuning an existing model. Thank you.
Thank you very much, Mercè. I think that was fantastic, and I hope everyone enjoyed that introduction to AI, that overview, and two really good examples of how it's being used. We live in a world where AI is infusing our everyday lives in many respects, and in which our professional lives are also interrelated with activities in AI, as Mercè has described. And so we need to consider how we respond and how our science system responds. We'll hear now from Vanessa McBride on that topic. And I'll hand straight over to Vanessa.
Thank you, Simon. Hi, colleagues. It's really delightful to be here on behalf of the International Science Council this week. And thank you very much to CODATA and the World Data System for inviting us. We've got the delightful opportunity today and this week to launch these 3 primers around AI. And as Simon was saying, really, what we're thinking about with these primers is how AI is affecting the way that we do science. And Mercè pointed out that, AI is not anything new, but it's certainly new in the public consciousness with the launch of ChatGPT a couple of years ago. And that's really played out as well in the broader scientific community as people are exploring using these kinds of large language models and are increasingly becoming aware of other forms of artificial intelligence that can be useful for doing science. And as with all these new technologies, there's a lot of promise. There's promise in terms of accelerating the pace of scientific discovery, of using the kind of large data sets that science generates in a different way. But of course, there's also concerns that relate to the process of scientific integrity. And so this, we think, from the International Council of Science is a really interesting thing to explore. So just to set out the vision for the Council, the vision is science as a global public good. And if you want to explore that vision in more detail, then this is the link to the publication from a couple of years ago that sets out what we mean by science as a global public good. But it's based very simply on the fact that knowledge claims and evidence on which they are based are made open to scrutiny, but also on the other side of the research process, that these results of scientific research are communicated promptly and efficiently so that people can use that research and act on it. And as we see, in fact, even from the founding statement of CODATA, an increasingly large amount of scientific knowledge is generated now on the basis of this data. And so by implication, there's a need as well for data to be considered in some senses, at least in the scientific context, as a global public good. Just a little diversion about what the ISC is. We're a non-profit organization. We're a membership organization where all of our members are also organizations. So we have a broad geographical representation. We have about 140 members in different countries. Mostly those are science academies, but in some cases they might be national science funders or a different kind of institution. And then we also have international organizations that have got discipline-specific focus. So that's, for example, the International Union of Pure and Applied Psychology or the International Mathematical Union. And so we really cover quite a breadth in terms of disciplines, but also in terms of international representation. So this week, coinciding with International Data Week, we're very happy to launch these 3 primers on AI for science. You're welcome to scan the QR code or to just follow that URL, which is council.science/AI-primers. And the 3 primers are on types of AI and how they are used in science. The other is on considerations on the environmental impact of using AI in science. And then the last one, probably most relevant to this community this week, is around data and AI for science. And the idea here is that these are really kind of basic entry-level documents that would be useful to provide a briefing or getting up to speed for science decision makers. They're not heavily technical documents, but they do contain a set of references that you could use for further exploration. And our thinking about why these documents were necessary really came out of some work that we did 2 years ago. Let me just see if I can advance the slide. There we go. And that was around exploring the readiness of national research ecosystems for AI. And as many of you might know, lots of countries have got policy documents that set out their vision for AI. And those are often looking at aspects like the use of AI in health or in agriculture or its impact on the labor market. But not too many of them consider the impact of AI on national research ecosystems and how that might need changes in those research ecosystems. And so this exploration started about 2 years ago. We have a collection of 18 country case studies, starting from Australia, going through to Uzbekistan. And we're putting together another couple of case studies. So if you have an interesting study from your country, please do get in touch. And we asked the authors of these case studies to what extent are countries addressing the implications for their science systems when they're developing these kinds of national AI strategies. And we asked them to consider a couple of key parameters: what policy tools are being developed, what institutions are pursuing this, what are the capacities in terms of skills, but also in terms of infrastructure, and are there specific funding tools that are being directed towards AI and science. And really, out of the first set of these country case studies, some gaps began to emerge. And those gaps were around data needs for AI and science. And there was lots of questions that came out around the sustainable use of AI. And so that's why we have these two sort of primers that are focused on these topics. The third one, which is about the types of AI for science, is really because often I think in these engagements we find we have to pull back a little from LLMs and just say that there's actually a much broader scope to AI and science than the LLMs. So just very briefly, I think because this primer is probably of the broadest interest to this community, I'll just highlight the recommendations that came out in this slide. The recommendations is around convergence to existing frameworks and standards, and I think we're going to hear a little bit more about that in the upcoming talks in the session. That there's a consideration as well to be given to data governance structures beyond the technical standard that also has to promote things like equity, access to resources and skills development. And of course that if you're talking about these in many contexts, that has to come with commensurate investment. And then the final recommendation is really around providing some more overt recognition and incentives for careers around data stewardship, because we see them as so fundamental as the building blocks really for the kind of scientific knowledge generation that is happening through these large data sets and through AI. So as a kind of a summary for this, we see that there's a huge dependency on well-curated and machine-readable data with many other considerations for AI. We're also seeing contextually aware approaches that have the potential to accelerate and build on scientific discovery. We also see the other side of the coin, where we see the employ of AI techniques as data curators for scientific data, and we've seen quite a few examples of it in this meeting this week. And of course then I think an important consideration is to bear in mind the biases and the structural inequalities in the data sets themselves, and that of course links back to some of the presentations that we heard yesterday morning. So just to give you some ideas of things that I would like to discuss when we have the discussion session, some of the hurdles to data in context for AI to science, this would be good to chat about in collaboration with CODATA. Also, what does the science data community want to advocate for in terms of global policies on data? So the ISC does scientific coordination. It also looks at policy for science and providing scientific input into multilateral policies. Are there particular things that we should be aware about as the international data community that we want to highlight in terms of policy making? And then, of course, maybe more of a philosophical question that should be underlying our work. What is required to ensure that science remains a global public good? And just a last point to highlight that there is an open call with the UN for an independent international panel on AI. And I think it's quite important that this community also participates in that open nomination process. So thank you. I'll leave it there and happy to continue in the discussion.
Thank you very much, Vanessa. And really, please do look at those primers, and they'll be very valuable for this community, and reflect on those very helpful questions that Vanessa spoke to. I'm going to invite Tyng-Ruey and Christine to the stage, please, who will present, as I said, their thoughts towards a CODATA White Paper on the role of data in AI for science, and ask for your feedback.
Thank you so much, Simon. And as someone else said, thanks for getting up early and being here. Brisbane is so inviting, so it's a real honor that you would come here for this session. So I'm Christine Kirkpatrick from the San Diego Supercomputer Center, and also CODATA Secretary General. And it's been my honor to work with my XCOM co-member, Tyng-Ruey. What we have today is a concept paper that we've developed that we're now ready to get feedback on. It's been the work that started over a year ago in Barcelona with many of our colleagues in the executive committee and the secretariat and the other officers, where we wanted to do something that didn't add to the noise, that really tried to focus in on data, because so much of the work of AI is all about, well, the marketing hype, and then more about algorithms and the chips used, and there really isn't enough on data.
So I will, Christine and myself will present this together. But if you excuse me for the slide, I'm going to speak. I have a script. So the advance of science is a common enterprise, collaboration across national borders. Research institutions and academic discipline are now a norm, facilitated by tiny dissemination of research publication and data. Research workflows are becoming data-driven, and the research data management is an essential part of research teamwork. We are all aware that research data production and reuse is collaborative in nature. Here we give 3 examples. In April 2017, astronomers aggregate a huge volume of observational data from telescopes operated by multiple research institutes, totally 3.5 terabytes, in order to compute the first image of black hole. Biodiversity data set from GBIF, the Global Biodiversity Information Facilities, which are themselves contributed by researchers worldwide, has been referenced by more than 10,000 papers of 2024. As mentioned by previous 2 speakers, AlphaFold, an AI system that accurately predicts a protein 3D structure from amino acid sequence, has been trained on publicly available data. At the same time, large language model has been built on material cloud from internet and other data sources without the same collaborative spirit. The heavy traffic from AI crawlers induces a heavy burdens on the infrastructure of web resource providers, for example, Wikipedia and many research data repositories. It remains a challenge to maintain an environment in which the production and the consumption of resources is based on reciprocity among the actors who are involved. Rapid advance in AI technology, however, has the potential to ease and speed up knowledge sharing and discovery. CODATA, as an organization, here I quote from his website, a vision of a world which science is empowered to address universal challenges through the transparent, trustworthy, and the equitable use of data and information, unquote. It's in these visions we are starting to collect thought from the research communities about the roles of data in the context of AI for science, and to develop together a set of recommendations by and for the research data community to advance the current practice.
Okay, and so and we were banking on Mercè giving an intro to AI, so thank you. And we look forward to reading the ISC primer, which will also be wonderful to have out in the community. But we tried to really focus in on what aspects of AI relate to people like us and where to focus. That we didn't want to boil the ocean and figure out what every tech company was doing or every branch of AI, like we're not concerned about robotics. But we were very intentional in saying that we were going to look broadly at machine learning. And then, of course, deep learning is where a lot of the activity is these days, especially with generative AI and LLMs. But machine learning still includes things that many scientists are using today or even aspiring to use today. Things like Google Colab, BigQuery, things that you don't even need GPUs to do. So there's still a lot of space. And then separate from the machine learning branch of AI, and I also use the Russell and Norvig's definitions of things, is knowledge representation, which is closely aligned with a lot of concepts in information science. How are you describing data and representing that? And then the practice of that, knowledge engineering. And so we struggled. We kept wanting to find a definition that someone else had written, so we just say that one, you know, like how we just said Russell and Norvig's way of discussing AI. But we talked about it so often that one just came out over and over, and so this is the one that that we're using here. But I do, as Mercè said, I think it's very complementary with what she also showed. So most simply put, AI readiness for data is a spectrum of how ready a given set of data is to be used by an AI process without need for further pre-processing or curation. And we talk a lot about what it means for data to be AI ready. So thereby using that same logic that when data is ready to be used without further work, you can call it AI ready. And most of the current literature, which is hard to keep up because there's so much actually being created by AI also, is really more about organizational awareness or how does a company become AI ready. But I'm so glad that this community is coming together to create some good definitions for that. And I think second and very important is that AI readiness is not a static state, just as becoming fair. It's not like, oh, we did it, you know, we climbed that mountain, now we can go to the next mountain. That the technology is constantly evolving. And so what makes makes your data AI ready today might be different next year. In fact, I would bet a lot of money it would be different next year. And so we did, we weren't trying to conduct our own literature review, but we did where there were places where we thought others have said this well, and places to point to. Also, we wanted to keep our concept paper short. And so we do want to highlight some very important contributions. The ARDC ecosystem paper came out just a couple months ago. And has some important connections, especially for the CARE principles and how to strengthen institutional data repositories. Of course, RDA and Microsoft have their whole series, and they had some, I thought, pretty helpful recommendations, especially along the human and workforce components. And we even looked at some things like software frameworks, like ADRIN, which tries to do a quantitative assessment and even has a security framework that they've recently added. But if you only look at one that we point at, I definitely recommend the ODI framework from some of our colleagues who have been deeply involved in the Croissant standard, which Slava is going to talk about next. So there's a lot of challenges, and so distilling them down to 4 was hard, but again, we wanted it to be something that digestible that people might read. So I think it's important to say that while we should understand the different challenges and the space of AI, we also need to be realistic that very few of us in this room, maybe like 1 or 2, are really going to be building foundation models. And thankfully, there are advanced computing centers that are building some open source ones. And for the moment, we have a tech company based one that's open source. But you know, placing all of our energy there about how are we going to build foundation models isn't reasonable. We don't have the money for the electricity or all the processors needed in most cases. And then to also be real that a lot of these issues are in black boxes at tech companies and proprietary. There's also some wacky stuff you may have read about where they take machine actionable data, stuff that we have prepared carefully in beautiful RDF type formats, and then convert it back to what it would look like if it was just on a website in text in order to feed it in. And then we have a slide on, we're going to talk about fair and fully AI ready not being the same thing, so I'll say more about it in a minute.
So I will continue with the opportunities that AI presents. AI offers opportunity in enhanced curation, workflow automations, and efficiency gains. So AI can transform traditional data curation tasks into supervised assembly of data graph, enable richer entity relationships, and ontology connections. AI agents and the Model Context Protocol, MCP technology, for example, can ease technical collaboration challenge and streamline research pipeline. Also, AI assistant on data stewardship tasks can help address the problem of duplicate efforts. In view of the community framework and the initiatives we too have studies and some of the discussion among ourselves, we come up with 6 recommendations for working with AI in the context of scientific data management. These 6 recommendations may seem self-evident, but we think they can be the starting points of engaged conversations. The 6 recommendations are: invest in data stewardship and the infrastructure, explore AI as a research data management tool, build foundation model with proper context, develop a new force competence, and collaborate in data production and provisions. The last is build tool and share practice. I will say a few words about the first and the last 2. Christine will do the rest. Invest in data stewardship and the infrastructure. I think we will agree that research and students involved in the management of research data will need more than a base level of AI literacy to ensure the data and management are still of the highest qualities. Current investment into research data facility must go beyond computing capability, data storage, and the network bandwidth. It must also put resources into the staff and the student to upskill their capability in working with AI in these rapid changing environments.
Yeah, and just in the interest of time, I won't focus on each of these, but I do think a very important and basic thing, and that's why it's so important that the ISC has put out these primers, is there needs to be more skilling up on both sides, right? We need AI people to understand more of the data side of things and some basic information science. And then we also need to reach to that other side, and not so that you're all doing machine learning, but so that you understand the concepts. I mean, it is possible you get a disease and you go to the doctor and they say, you have this, take this. So yes, we could say, here, take these recommendations. But I don't know about you, when I get something I want to learn about, well, why does it work that way? And why is the thing you're recommending going to help with that? And so that's the level that I'm suggesting, that and we need to think about how we educate the workforce and how we incentivize people to upskill as well.
About it. Sure. Yeah, I wish to emphasize the last recommendation, which is collaborate in data production and provisions. The protein data bank is a very good example of collaborative data production and provisions. And the research organization and founder should collaborate in building more and sustaining research data infrastructure, like a protein data bank. At the same time, communal networks for data collection and sharing, such as archive preprint server, GBIF, Wikimedia Commons, and Wikidata, just to name a few, should be recognized and supported by research institutions. It's important to strengthen partnership across institutions and the sector to ensure data sharing remain based on reciprocity and mutual benefit rather than extractions. The last recommendation is building tool and share practice. Building and applying AI system involve a lot of work, and the people need to share tool they build and to share their experience.
So, and we say, instead of saying that the new fair is fully AI ready, maybe it should be functionally AI ready, and that it's a continuous practice. Again, it's not that destination you get to and it's all done. That would be nice. And that it's also an aspiration. It's more like a vision and a spectrum of things. And I think also importantly, AI is not one thing. What you need for machine learning and using BigQuery is different than building a knowledge graph, is different than fine-tuning a model and building an LLM. So we need to become a little bit more literate in how those things are done so that we can properly prepare our data for that or protect our data if we don't want it to be used that way. And this will take investments in all of the things that in America we call cyber infrastructure, others call e-infrastructure. Okay.
Thank you very much, Tyng-Ruey and Christine, and for those very clear recommendations. And I hope the audience will reflect on those and ask questions of them. Hand over quickly now to Slava, who will talk about work that he's doing with colleagues on Semantic Croissant, the role of CDIF, and really putting some of the things that we've heard into practice. Thank you.
Thank you, Simon, and thanks for this opportunity to present this, I think, important work. So today I'm going to talk about practical things and specifically about Croissant standard. And you may argue, why do we need another standard? We have a bunch of standards and probably we can use them also for machine learning. But this is not really true because, as you know, in LM world, everything should be precisely described and there is no actually possibility to make mistake because you can produce completely different results which will be considered as invalid. So we started to work on Croissant together with Google 2 years ago, and there are also a lot of people contributed to this standard, and it's still evolving, and now we have Semantic Croissant, which is a combination of Croissant with CDIF. And this is about my talk about this continuation of development. So as you may know, most of machine learning data sets are uniquely unstructured, and we need to bring structure. We also need to have possibility to combine different materials like images and text, video, and to be able to analyze them in the same pipelines. We need to do harmonization. We need to use different frameworks. We need to also use frameworks built by different commercial parties. For example, like Keras, TensorFlow, any kind of other frameworks will be developed in the future, should be able to understand these new standards, and we need to use them. So this is time for responsible AI. So if you are really interested to understand what is Croissant, there is a spec, and as I already said, a lot of commercial partners like Google, Meta, and someone else like NASA and Harvard, they contributed to the development. And it allows us also to produce AI-ready data on the spot. If you'll press button publish, for example, in Kaggle or in Dataverse, on OpenML or Hugging Face, it will create Croissant for you. And this Croissant is already AI-ready. So you can ask any kind of AI model, LM model. You can ask questions and it should respond to you, which is very interesting. Croissant by itself is consisting of 4 different levels. So first level is basically is traditional dataset description based on schema.org. And second level is resource description, where we have information about files, archives, and information about types, like if it's CSV, Excel, or something else. There is also context structure, and it's agnostic to specific data types. And even more important, there is also ML semantics. And why you need semantics? This is very interesting because, as it already said today, any kind of data set has only description which is kind of static. And what you really want to make it as a graph evolving. So it's live knowledge. And for that reason, you need something like CDIF to package knowledge and also to make it evolving in time. Okay, so back to responsible AI. So this is really interesting topic as well, because responsible AI is based on our previous work on DDI. For example, Data Documentation Initiative, DDI standard, was created more than 20 years ago, and now we want to make it also available for AI. So AI should be able to understand what has been created before, should be able to also to ingest inside of LM models or any kind of models, and this information should become available also for researchers as a part of the process. So we want also to make it really clear for researchers how to use that. And if you want to also create metadata and combine with live knowledge, which is evolving, you should use combination of Croissant and CDIF. So this is how DDI variables are described at the moment in XML files. And it's not really what AI expecting from description. You should also have some information about attributes, categories, and units of measurements. And again, so this is live knowledge. So it should be, we should be able also to make static copy of that, and also let researchers to work on a new knowledge, which will be incorporated and linked to previous definitions. So there is a checklist how Croissant can be integrated with CDIF to make AI-ready data. I will not go into details, but I need to stress that you also need persistent identifiers for every variable, and you need a specific description for every variable as well, and you need descriptions for phenomenon. But in the same time, you have to allow researchers to produce new knowledge and change those descriptions and link to previous work. And it will allow us to take snapshots and also combine with Croissant and after train new models. And this is how models development will be evolving in time. So in CDIF, we also have a schema definition. So we're using not only ontologies, we're using also control vocabularies. We're trying to find some descriptions were made previously by someone else, and if it's possible to link to them and use this description to train models. And if it's not possible, we need another kind of infrastructure to create those descriptions, and also to use AI assistants, basically to make references to some descriptions that are created by some other groups. And all of that information will create a graph which will be used for AI agents and AI models to produce further knowledge. So by using this approach, you can actually quickly create any kind of new research and work with your colleagues, but in the same time, AI will become your assistant and it will contribute to your own research. So just practical example how it should look like. There is a spreadsheet which was converted to CDIF representation. So as you see, it's a graph. And graph means that you can query it. You can also get access to revisions. You can also understand what kind of versions you have. And you can also get latest version, which will be incorporated in the AI model. Even more interesting, as soon as you are using ontology alignment and control vocabulary linkage, like in this example, it was linked to Wikidata concepts, which are used to train models, of course, because everybody is using Wikidata and Wikipedia as a source of ground truth. You can already use it also for your own processes. So if you do that and you have some description of variable, you can also ask AI can you actually tell me if it's relevant for this context? And if yes, you can keep and you can create knowledge. You can create link to this knowledge. And if not, you have to create and describe completely new variable and link it to other variables. So now I'm coming to the point where if you do everything right and you have Croissant and you have CDIF integrated with Croissant and everything will be linked in Croissant as reference, you can also think about AI assistant tools which are basically making you suggestions how you can improve your metadata and what kind of variables you can introduce and what is actually missing. And it's really amazing because this kind of process is actually giving you very straightforward tips, for example, about licenses. So it's giving you information how you can improve or you can change your license, how you can connect to the work of other people, and how actually AI can elaborate your own work, and in a way also it can criticize your work. So thank you, and if you're interested to know what will happen next, just listen this old song from 1979. It's called "In the Year of 2929." Thank you.
I'd like to call the speakers up to the panel. So thank you very much to all the speakers. I think what Slava just showed, that checklist for CDIF and Croissant for AI-ready data, and the tool for metadata enhancement, the assistant for data stewardship, is potentially really exciting. So, are the helpers here with mics? Yep. Are there any questions from, I can see 2 hands went up in front of me. It's a little difficult here with the Gestapo-style lights in my eyes to see who is putting their hand up.
Thank you so much. My name is Harish Kumar and I'm a doctoral researcher from University of Vasa from Finland. So there was a presentation about AI definition and AI models. So at that time, one question popped up in my mind. I wanted to ask, but Slava, you mentioned about the tool. So that was kind of answer of that question, but still I wanted to ask to elaborate further. So what you think, like, because nowadays everyone is using AI, there's no limitation of AI. And I had discussion with one guy that people have been using AI for simple mathematics problem, addition and subtraction problems. So we are being too much dependent on AI that like we don't want to use our intelligence. And also I had a discussion with people from different fields, from natural science and other fields. So natural science people, they don't trust ML and AI. They say like, we believe you need to tell us that like how this physics is working, what kind of a mathematical equation, mathematical models we can use for this purpose. Some people, they have been still stuck with the fuzzy logic. They think, okay, this is the thing that we can explore more. So do you think that tool that you mentioned can be used to develop this kind of validating standards that can define for your work until what extent you can use AI in the science? For example, some people, they have been using AI for writing scientific articles. Some people, they have been using AI for developing methods. So do you think in the future we have this kind of validation standards?
Thanks. I think actually that maybe that's first a question for Mercè, who, for the role of AI in science, and then for Slava to follow up on the validation from the perspective of data and metadata.
Yes, I mean, if I understand well the question, I think that well, validation probably is used in very different contexts. So I just want to be careful also, because when I use validation, I meant the standard process that you use when you're either fine-tuning an AI model, so that you're going to do iteratively with the training data and the validation data to find the accuracy of the results of the model, that model. So I don't think you're talking about that validation, but if you're talking about having recommendations or what set of descriptors that would tell you these are AI tools that are used for this part of your research life cycle. I think that, yeah, we're moving towards that, and also to understand that in some cases there is no need for an AI, for AI, right, as part of that process, and not only that it's not the idea that the research life cycle is completely substituted as an automated process. There is a human in the loop, of course. But yeah, I think that we could create tools that are well self-described to see these tools. The purpose of this AI tool is for this part of the research life cycle. And I'm not sure that answers enough your question, but that's I think that we're moving towards this, right? To do specialized tools for the specific purpose.
Yeah, this was your answer, but like my question was asking for, do you think like in the future there will be some kind of a framework that will create limitations of usage AI based on the region-wise, EU-wise, or APAC-wise?
Right. I mean, I think that every tool, well, what I know about the future is, like all of us, it's very hard to predict for any of it, right? What it will be. But I think that we work towards that we describe the limitations. So any AI model or AI system that it's a pipeline of models, for example, should describe itself with the purpose and the limitations. And the limitations could be the accuracy that you get in the results. I mean, how well it performs for what you wanted it to perform, right? And that should be part of the documenting that AI system. Is that?
Thank you. Slava, do you want to add anything about validation from the perspective of the metadata and the data?
Yeah, so AI is evolving very fast, and as you know, we started with LM, and now there is Model Context Protocol, which is also developing very fast, and you can see a lot of applications being created and a lot of tools were built, and basically what you want probably is to use LM as a kind of gateway, kind of entrance, where it can understand what you actually want to do, and after it will run tools that we already have with all parameters, and as a part of responsible AI, it will be able to connect different services and also to document everything properly, as I just showed.
Thank you, Slava. I think someone has the mic over here, then we'll go back there, and then we'll go here.
Hello. Eric Laurie from the Australian Institute of Marine Science. I was quite interested about hearing a lot of the AI ready, setting up data sets to be AI ready. And a lot of the focus is obviously around creating and formatting data sets so that they can be ingested and hoovered into machine learning models and making that process as seamless as possible. I think one of the things is I represent a lot of environmental data where a lot of that data is structured in ways where it's actually probably not suitable for machine learning, like multi-dimensional hydrographic data, right? But scientists want to use that data. So what I wanted was your comment on how we can make our data sets prepared in a way such that LLMs can assist researchers in conducting science, not training models, but conducting science with data.
Christine, do you want to take that?
I think there's some pretty good techniques people are using already, which is where you take some complex data and you create knowledge graphs, and then you use an LLM as the natural language interface to the knowledge graph. So you, as someone who knows what the data actually represents, and you can give it the proper context, and you know how things are connected. You make sure that works well. And then, yes, they can ask weird questions and foul up things that way, but they can't fundamentally put put the data together in crazy ways that, that they might if they were just taking it and trying everything out from scratch.
Vanessa, did anything on that topic?
If I can, I wish to comment that I'm more inclined to think that data is something in the process instead of end product. So we cannot envision all possible future applications. So what we can do often is that we document the data sufficiently such that it will be easier for them to be reused.
There is some work at the Barcelona Supercomputing Center with the Earth Science Department, and have similar data that you're describing, that work towards that, preparing it for use as the input of AI models. Yeah, so we could discuss that if you want.
Yeah, so I just wanted to add that we started to work on Croissant together with NASA. And the point is, it's very difficult to do research if you're tracking all these measurements coming from other planets. And if you can do that, I think you can manage also to do all this research that you are doing.
Thank you. We'll take the question from over here. Do you have a mic? Right, okay, bye then.
Yeah, Stephen DeCosta from Link Digital, but I'm also here representing CCAM, which has a Croissant extension. My question was just around the white paper for stewards and such. I just wanted to ask, did you consider using more sort of like observability-orientated language rather than data, as data being an after effect of some sort of process that might have perceptibility, signals, all this kind of stuff, considering AI will be put in presence to places to then take data as part of a feed. And then with that, the second part of the question is, did you consider making something more like a social justice or data justice type statement to go with it to protect or have some sort of vision for natural rights with regard to facts, reality, things like that?
Well, and I brought my notebook not because I have all the answers, but because we really were real that we wanted some feedback on and we're writing down all the good ideas. And actually, while we were on the podium, I even got some of them texted at me. So I think those are good questions. We tried to make a concept paper that wasn't super long, because when they're too long, nobody reads them, and to provide some pointers. I would say, not as a cop-out, but our inclusion of the work that ARDC did and where they pointed to some of these ideas, I think is maybe could be, if anything, lifted up more. But so we do have that link there. But yeah, it's not, it doesn't include every concept. And I'm not sure I heard the first question right.
Yeah, I didn't understand the first question, I'm afraid. Can you repeat that? Do you not have the mic anymore?
Yeah, I think that one of the recommendations is to build tool and share practice, meaning that the knowledge should be universally available to the entire community, not just to the scientists. And I really appreciate open source tool like CCAM. I think you mentioned that actually we build a data repository on top of that, and the source code for the repository are also available to anyone to use.
I think Vanessa would like to comment.
I actually just wanted to comment on the point of the second part of the question around the data justice. It's not something that we've explored in the papers yet, but I think going forward we're looking at ethics issues in science around emerging technologies, AI being one of them. And this is something that we could engage on if you were keen on the white paper in context with our Committee for Free and Responsible Practice of Science. So, but if there are other inputs on that, we're happy to have them as well. Thank you.
Yeah, I think that issue of natural rights is really important in this context. Do you want to reiterate the first part, or should we?
Yeah, I guess just for the record. So observability in the sense of, like in the Linux kernel, there's open telemetry type projects designed for observability, telemetry more so than data, given that AI will be in process, in train.
Okay, maybe that's a question. That's a topic that we should speak offline. Yeah. Yeah. Oh, do you want to respond?
I was just taking it as a note to follow up and
Okay.
include. I mean, I think it's important to get something out there that people can react to, and then the organizations that we all represent are places where we can fully explore these. And I mean, really, social justice, I think all of us are under threat unless we're head of a big tech company, you know. And so, of course, people who have less power to stand up for themselves need that. But I think we're all in that same boat, and there's some really existential issues that come with AI.
I think at least the process should be fully documented and transparent. That's the first step.
Yeah. Thank you, Tyng-Ruey. I think that's an important point. There's a question here.
Thank you, Simon. I'm Geeta Yadav. I'm also a member of the International Data Policy Committee of CODATA, and we've had these debates for years and years. I'm very glad to hear AI architects like Slava here and policymakers like Mercè on the stage. My question is to both Mercè and Slava. You know, we are constantly calling for explainability in AI. Within India also, we are doing a lot of explainable AI efforts right now. But as our models grow more complex, interoperability can come at the cost of performance and speed. So do you believe on stage right now, personal views, that the scientific community should accept black box breakthroughs even if they lead to faster discoveries? It's kind of a question between ethics and tech, I suppose. What do you think, Slava?
Okay.
Mercè.
If you don't mind, I'll start, but also Slava add whatever. No, I don't think that we should just accept a black box. Actually, not. I think there is a lot of room for using open. As I said, the description of open could be. I mean, it's a whole spectrum, right? And the definition of open, and as OECD puts it, you need to think of what do you mean by that. But I think there is a huge gap or a huge difference between just saying, I'm taking something that I don't know whether there are not open weights, I don't know what data has gone to pre-train those models. I don't know, I cannot fine-tune it or so because I cannot deploy it because it's not open source and so. Then it's a huge difference from all the other degrees or the range of uses that you can do where you can, you can be transparent about what data have you used to train the model once it's been pre-trained, right? That you have an idea if that model that you use to start with a foundation model has the data. I mean, if it may already have the data that you need to train you would need to train again, or that they are relevant to you. And in this case, you don't need to do fine-tuning, but you need to describe very much how you used it, how you validated that the results are correct. So there is, again, from going to doing everything in a way that it's not, doesn't have the transparent workflow, the transparency about the prompts that you used or the training data that you use, and so to having everything completely open. That might be difficult in some cases. I think there is a lot of room in between to do things in a more responsible way. That we understand more what has happened in the process, right? And I think that putting standards about how open we're going to be about the use of these models, right? How we describe how we use them, how we validate them, how we test it afterwards, right? How it is, in what purpose it's been used, and what training data has been used, what prompting, if there is prompting, has been used. I think this is essential for science. Otherwise, we're giving up too much. And also about the explainability of the models. I just want to say that I know there is a lot of work going on that in computer science, but it's still extremely hard to do that. So, I mean, I would be skeptical of saying that we have full explainability of these. That's why we need all these definitions of openness in other ways, right?
Yeah. And I think the OECD report that you pointed to looks extremely useful from that respect.
Exactly. Yeah. I think that the OECD guidance is what we could think about it, or at least not be in the side that everything is closed. At least one of those things that were listed in that guidance should be open.
Yeah. Slava was asked to comment as well, and then we have a question over here.
I will introduce new term, inflation of large language models. This is what's happening. So first, we started to train models, and they become very large, and it was impossible even to run on a local laptop, right? So now you can just deploy any model, and you can use it locally. And in a graph-RAG context or in connection to external sources with MCP, you can get all explanations from where information is coming, from where data actually is stored, and how it's being processed. And you can, again, create documentation and put it and share with other people as a new knowledge. This is how I think it's going to happen.
Sorry, no, we want to get to the questions, but what if Tyng-Ruey and I had got up and one of our 6 recommendations was, don't use ChatGPT because it's a black box? Like, do any of you care if I say you shouldn't do that, or are you going to stop doing that? And even if you all said, okay, we really respect you both, so we're going to stop using it because it's a black box. Are your grad students, or your undergraduate students, or the people in your home going to stop using it? Probably not. And so I think we need to think about, be realistic that some of these products are pretty great, and a lot of people are going to use them. And where our power is perhaps even with tooling, calling out where some of these issues are and using things within our power, things that we can get funded to kind of chink away at the armor of this black box and to show where the problems are. Early on with the social media issues, we had groups working on misinformation and it was just a few people in research groups, but they were making national and international news stories showing, X percentage of Twitter accounts are fake, and things that now we all totally accept, and yeah, we know that. So people in this community partnering with computer scientists and joining with others in other domains, we need to start working on these what might seem to us as small projects, but that have big implications and kind of show and expose some of the issues. And that is the way that we can combat that. I don't think we're ever going to, it's too late, right? HPC, we did a good job in the academic community. We were right there at the forefront. But AI, the companies have too much money and too much power and too much hardware. So we have to think smarter about how to bring them back to openness.
Can I add to that? I'm sorry, because so I understand that we can, well, it happens in all academia and in science, and so just putting rules about you cannot do that, it doesn't work. I would suggest, though, to think very, very hard, very, very cautiously about using ChatGPT for what. One thing is ChatGPT, I mean, there are some of these closed models, that there are some parts of our work, well, it helps us with some parts of our work that might be appropriate. If you know enough about the subject that you can tell that the answer is actually correct, because otherwise it will fool you. The less you know about the subject, the easier it is to fool you. But at the same time, if you're going to do, I mean, if you're using AI as part of your scientific discovery, as part of your inference for science, I think there I would want to be very careful. There are other, smaller, as I said, and some studies have already been showing that, smaller open source models that are as accurate, if you train them and you know how to fine-tune them, or you use them in a way that you're validating them, they're going to be even better than the larger models that are much more computational resourceful. So I don't say don't use it, but be very, very, very careful about using it. And there are many other options that are easier to use in the context of science, because it's easier then to describe it, have more control of what you add to it, and how documented it openly And so they are more aligned with the values of science. And I think that it's worth thinking of that.
Thanks, Mercè. I think that's an important point, more aligned with the values of science. We'll have to take this as the last question because we're running out of time.
Thank you for the session, very interesting. If context is everything...
Could you introduce yourself?
Oh, right, forgive me. Esmond Owen, University of Nottingham. If context is everything and everything is context sensitive, why, it's heartening to see you've mentioned context, why is context never represented? And are we fundamentally missing something around the use of context to help our understanding of data and thus the better use of data?
I think that's why we included the other branch of AI, knowledge representation, because it's all about context, and everything with knowledge graph is the data plus the context. So I absolutely agree with your point.
Yeah, and I think a lot of what Slava was describing as well, the objective interest, to use OGC terms, that phenomenon, the other contextual information in the graph, the variable in particular, these are essential areas of context. And we have a group in the cross-domain interoperability framework work which is looking precisely at context, provenance, and quality as three linked concepts and objectives and things that we need to do in the metadata.
No, I think I wanted to kind of make the same point you just made, Simon, that it's not only about context, about where the data's come from, but of course context and how it might be used in the future as well. And I think there you still have to use, some of our expertise as scientists and as data stewards, and a kind of an intuition in some cases, in knowing what that context would be, what would be relevant.
Yeah, I completely agree, Efren. I mean, the future is knowledge graph, not large language models.
Okay, I think that's a good point to end on. Thank you very much to the speakers and the panelists. I'm very grateful for your attendance and your engagement. I strongly suspect we could have continued those questions for some time, but I know that you are also in need of caffeine or whatever your drug of choice is. I'd like to close, please, by reminding you that this was the launch of those ISC papers. So please do download them. You had the QR codes, you had the links. Please do peruse them. Please speak to, contact Tyng-Ruey and Christine and give them any feedback on the ideas and the recommendations that they presented. They will be very grateful for that and would be delighted to engage in conversation with you. Thank you very much.